So here we go with number 3 and 4. The triangle is formed by the x-axis, the y-axis of the line, y equals 2 minus 1/2 x. So hopefully you saw that that's, this shape right here, same number as 2 and 4, but this time it's forming a triangle. All right, and we're going to rotate that about the x-axis. So that's what we're looking at first. What does it mean that I'm going to rotate this around the x-axis? So again, what I usually do is I'm going to try and create a mirror image across the x-axis. So it looks like I went about 2.5 there. So I'll go like that. All right, some of you guys are going to use like fancy drawing tools like rulers and such. Be nice. Now the sort of round end is going to be over here, so I'll put my ellipse on this side. Try not to make too much of a mess of it. All right, there you go. And you can like indicate that the back side is not visible if you want. Make your cone sort of semi-translucent, and then do some more. We'll do some more fancy shading, sort of like that. Make it look coney, look a little bit like a cone. Yeah, I don't know if this is going to help back there, but there you go. All right, so it looks sort of like a cone. Okay, it's cone-like. It's a cone. That's because it's a cone. All right, and so the volume of the cone we know is 1/3 pi r squared h. So that is 1/3 pi. The radius is 2, so that's 4. 4, so I got 16 pi over 3 for my. That's a 3 for my volume. All right, that's that one. So that's rotated around the x-axis. Now we have the idea by now that if I rotate around the y-axis, the same class of figure, still a cone, but it's going to have a different volume and it's going to look pretty different. So I'm rotating it this way. It doesn't matter which direction I go. And so first I'll create a reflection across the y-axis. Looks like it's not very symmetrical. I seem to have trouble with that. And then we'll just draw like a big flat ellipse down here because this is a big flatty cone. Flatty cone face. There we go. That sort of looks cone-like. We could imagine the back side of the cone sort of looking like that-ish. We can put some shading effects on this one. I don't know if that helps or not. Maybe a little bit. There. It's another cone. Okay, so I got a cone, and this time my volume being 1/3 pi r squared h is 1/3 pi. The radius now is 4, so that's going to be 16. Height is 2, so now it's 32. Oh, well, if you think about it, the cones are just the same as the cylinders divided by 3. Yeah. Okay, so this is your basic idea of rotating a region in the plane around an axis and generating a solid, which you then find the volume of. So that's what we're really about doing. So next, we're going to do the actual calculus-y part of this, which is our number 5. So in number 5, you have this parabolic region. So that's what we're really going to be concerned with. So I have the y-axis, the x-axis, and 4 minus x squared, which is pretty easy to figure out that has a vertex of 0, 4 and x-intercept at 2, 0. So that's your parabola, which I did not draw terribly well. So let's do it asks first for the x-axis revolution. Let's see if we can look at actually both of them, even though I only asked you for one. Let's look at this. First of all, we're going to look at the x-axis revolution. All right, so I'll create a reflection across the y-axis to start, and then I will say that this, I rotated on the y-axis. Ooh, okay, well that's good, fine, we can compare them. This is a y-axis rotation, which is not what number 5 asks for, but I rotated around the y-axis, see? So then let's make this kind of bulby like that. And you basically have like this sort of a bullet shape, or like a rocket capsule, right? The landing capsule of a SpaceX Crew Dragon, maybe something like that. All right, so it's like a sort of, it's almost like cone-ish, but it's flat on the top. This shape has a name, but by the way, not all of the shapes that we do, in fact, most of the shapes we do are not going to have names. All right, but this one is called a paraboloid. Paraboloid. Yeah. And the question is going to be, how do we find the volume of this? So now let's look at actually revolving it around the x-axis, which is what number 5 asks you to do, where we have the 2 and the 4, and we're going to do the x-axis rotation. So here's this shape like this. All right, so I'll create a mirror image down here. I have like, you know those old-fashioned bells that they put on desks and you bing, 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 bing? It's like one of those, but on the side, on its side. This one's a little too pointy to be one of those, but this one's definitely your classic desk bell shape. And a lot of times we're still going to be looking for these types of analogies. Oh, I've really messed this up back here. In order to describe them by relating them to objects we've seen before. But that's always a trick. So there you go, sort of this thing. So it's like a, you know, it could be a cup or a bowl, but remember that it's solid, okay? It's not open. You can't put water in it because it's solid. All right, so that's this. This is also called a paraboloid. So our next job is going to say, if I have this figure, how could I find the volume of this figure? I don't have a formula for it, but Gertie thinks she does. What do you think, Gertie? You got a formula for that? No, all she got is hair. All right, that's what we'll do next.